to some Q&A. If you have any questions, please use the Q&A chat box. I'll also be checking the regular chat. So if you have any questions, feel free to ask. I'm going to go ahead and start with our first question, which is, can I use the INS USB 2 PC interface module with more than one sensor? Ken, is that?
Yes, you can order this device with a connector on it, and you can actually rescale it on your PC with a different type of transducer, just ordering it from us with the mating connector. So, yes, it's possible.
And how do you know what sample rate is required?
All right, I'll take that question. It's hard to say. Typically it's not going to necessarily be totally obvious, but typically you want the sample rate to be somewhere in the 7 to 10 times the event that you're trying to capture. So say you had something that's happening at 10 times a second, you may need up to 100 samples per second for your sample rate. If that event, though, that's happening 10 times a second actually only takes a millisecond for each event, then you may need, say, 10,000 samples per second. So you really have to analyze what it is that you're trying to capture, and then, how long does that event last, and then figure out the sample rate that's going to be somewhere in the 5 to 10 times faster than that.
How fast will the peak valley function on the 9860 respond?
It'll respond immediately because, as Keith described earlier, it has a collapsible filter. So once it sees a spike in the weight change, it automatically moves to the next reading immediately. And it's limited by the display update rate of 230 samples per second.
Related question. So I know, Keith, this is going to be your specialty. Do you offer a contactless torque sensor? And this would be a torque sensor that does not require bearings and seals, which would distort the reaction torque reading you're trying to measure. A little bit off the instrumentation topic, but we love torque too. So.
Yes, we do love torque. Yes, basically contact sensors. We have one, which is our model T11, which is a shaft style sensor, which basically spins bearingless inside of a stator, and the stator has to be held precisely around the rotating part so that they don't crash. That sensor actually comes with some little spacers that allow it to be easily installed and spaced, and then you pull the spacers off after installation. That's induction for the power transfer, and for the signal transfer, no bearings, just an air gap. We also have something called a model HRDT, which is a torque flange, which again is bearingless, uses an induction power transfer scheme, and then wireless telemetry for the data transfer. A couple other models would be our T27, which is a hollow flange type sensor, which again spins inside of a stator, but there's actually no contact between the rotating element and the stator. And then last but not least, our T1, which is a torque flange that has couplings attached to it permanently, and that's a bearingless sensor as well.
You can. Is there a way to verify my 9860 indicator is scaled properly in the field?
Yes, as Keith mentioned earlier, he talked in detail about the shunt cal or RCal function on the 9860 indicator. Basically, what that does is it's simulating a load, basically taking the load cell out of the circuit and putting a resistor in the circuit. So that's a known load. And on the 9860, we've got a button on the front where you basically press that RCal button. So what you do is when the indicator is scaled, and we'll do this here at the factory, we'll also immediately capture the RCal value, and we'll record it onto the cert. that you receive. And then when you're in the field, as long as you have that information with you, you can, a lot of people like to just put it right on the indicator or carry the cert with them. You can push that RCal button and that value can be checked versus the original calibration RCal value that was captured.
You have software available, DAQ or logging, for recording the input from a multi-axis. Got a 5210XYZ 2K capacity load cell, as well as third-party string pots simultaneously.
I'll answer that one. Yes, we do. We didn't get into it. We just limited our discussion today to certain instruments, but we actually do have some multi-axis sensors that are low volt sensors. 5210XYZ is one of those. Has 3 strain gauge bridge outputs. We have a 4-channel PC module, which allows a 4th channel, and that 4th channel could be used with the string pot. That PC interface module has software available for it, and it's different from the software we showed you today, but it basically graphs and logs the data. And so, yes, we'd want to look at the exact string pot to make sure everything's compatible, but there's definitely the option for it to work with string pots.
860 software compatible with a 9840.
That's a good question, but no. The 9860 is its own separate instrument with its own separate software, and our preferred software for our model 9840 is our gold standard calibration software. So, but that's usually used to calibrate other load cells or other machine calibration. So the answer is no.
Know what filter level to use?
Well, that's another good question. It's a question we sometimes do ask the customer. In some cases, they don't really know the answer, and it's hard to say until you get the system installed. And so one easy answer to that is to try and choose an instrument that either has selectable filtering, and then you can fine-tune it in the field, or you choose one that has a fairly low amount of filtering, so a higher bandwidth, such as, say, 1,000 hertz. And then you may be letting noise through, but then you'd have to do the filtering in your data acquisition system. One way to experimentally determine it would be to have, if you have a repeatable process, you can apply a fairly heavy filter and then open the filter bandwidth up a bit incrementally and see, see what your data looks like. Basically, as you start to see, more and more noise, you would know you may have a little too much bandwidth. If you start attenuating the signal too much, then you'll know you're using too heavy a filter. So sometimes it can be experimental. Typically, though, if you know that something's happening at about 10 hertz, you might choose about a 100 hertz filter, for example.
How does a collapsible filter work?
All right, good question. Now, the collapsible filter, there's a couple different implementations, but basically what the software in the instrument does is it looks at incoming data and compares it to the existing display data. And if the input exceeds the existing data or the average data by more than a certain threshold, it'll turn the filter off. And then it keeps making that comparison until the two agree within that window again, and then it turns the filter back on. Typically, and that threshold is typically adjustable, by the way.
Yes. Will the signal strength affect the load cell accuracy?
That's a good question. The WTS, the way it works is there's a transceiver module attached to the load cell. And when the reading is, or the load cell sees force, the information is captured and then transmitted as recorded on the load cell transceiver? So the answer is no, the accuracy will not be affected because no matter the distance, it's sending, let's say, the calculated weight or the actual weight reading to the receiver, whether that's the handheld or the USB base station as found at the load cell site.
Calibrates load cells periodically, but I never see anyone calibrating the signal conditioners / displays. What would you say about this?
Oh, sorry. Good question. We actually do see a fair number of instruments come back for calibration, but typically they're attached to a load cell when they come back. We don't see very many instruments come back by themselves for calibration. There's a couple of reasons for that. One would be that many instruments aren't really capable of being calibrated. A signal conditioner or your basic digital indicator basically takes a signal and converts it to a displayed value. So it doesn't really have any internal calibration available. They could be scaled. For example, signal conditioner, we could apply a known 3 millivolt per volt signal and then scale it for 10 volts. People don't typically send instruments in for that, though. Some instruments, however, especially ones that have TEDS capability or displays like our Model 9840 that actually measure millivolts per volt, do have an internal millivolt per volt calibration. And those instruments should be sent in periodically to be calibrated. They don't necessarily have to be, though, if the customer is able to apply a load to their load cell and then scale the instrument themselves. So there's a variety of reasons why people may not do it, but they definitely can benefit from calibration, especially the ones that actually have millivolt per volt measurement capability. And in our case, it would be the 9860, the 9040, 9320. Those are three that come to mind. Another thing we have is a millivolt per volt transfer standard, which is a very nice, handy device that's used for calibrating instruments in the field. Basically has a dial on it that can be set to precisely output a certain millivolt per volt value. So for example, you might set the simulator to 3.0000 millivolts per volt, and then you can use that to scale the instrument in the field, or you can actually use that to calibrate the internal millivolt per volt values of the instrument. So a number of ways to calibrate these things. Coming back to the factory is certainly one of them. It can also be done in the field using a simulator or with applied loads or various other methods.
Steve, my bad. We have time for a couple more questions. If you have some, type them in. We have here, what happens if you want to clock two sensors together using the INF USB 2? Ken, I'm going to pass this one to you.
This can definitely be done, but it's under a different device called our SI USB. So this particular one has the ability to have a channel A and a channel B. They can both be clocked together. Now, if you do have applications that require, let's say, 4 or 8 channels, we do have other devices available for this. So, you know, feel free to give us a call if you'd like to do more than, you know, the 2 channels. We have a solution for that as well.
Please explain bit resolution. This could be lengthy.
Oh, now we'll keep it brief. Digital instruments convert the analog signal to digital and something called an analog to digital converter. And those converters have a number of bits associated with them, typically 12-bit, 16-bit, starting to see a lot of 24-bit converters. Basically what that means is it chops the signal into a certain number of pieces. 12 bits is what, 4,000 some pieces. 16 bits is 64,000. parts. So 16 bits is typically adequate. Some of our instruments have 24 bits. Some of them can make use of those extra bits. Some of them cannot. And so, you know, a million bits doesn't do any good if most of them are noise. So typically somewhere in the 18-bit range is beginning to be the limit of usable resolution. But it's basically how many pieces the input signal is chopped up into, and it limits the resolution of the device.